Solutions, Genetics India Private Limited. He is also representing the Automation Industry Association. Mr. Abhishek Pandey, Senior Manager, Digital Industry, Siemens Limited. And I also welcome Mr. Parth Kulkarni, DGM, Automotive Research Association of India. So while our chairman will join and give the welcome remarks in due course, I invite the first speaker for today, Mr. M. Sundaram, Associate Professor, PSG College of Technology. Our speakers today will dwell on the topic of relevance of automation of smart manufacturing for the MSME sector. Over to you, sir.
But how can you, all of them? Presentation already loaded. No, they know that. It's already there. But, is it comfortable for you, sir? Yes, I think. Pallavi, madam. I think speakers can also sit there. Do you have any short slider? Good morning, participants. Good morning, co-speakers. On behalf of PSG College of Technology, along with EEPC team, we welcome you all for this session. Probably this could be a good session for users and developers and also solution provider. We all know that Coimbatore is a place for entrepreneurial as well as for education. So as a first session, as usual, after education only people go to industry. All you know that. Hope in the same manner the session is also arranged. So I am Sundaram from PSG College of Technology. This presentation is about what we did and what we are doing, and which will be useful for MSME industries in upcoming days in order to automate their existing process. We established some center of excellence with the support of Ministry of Heavy Industry, Government of India, and also with industry partners from Coimbatore and from Bangalore and Pune. So this scheme is enhancement of competitiveness in the Indian capital goods sector, scheme 1 and 2, and I'm going to give the topic on talk what we did related to this automation and smart manufacturing. So we did 3 technologies in phase 1, which we started in 2016. So one is automated welding system for specific industrial applications, headed by Dr. Vinod, Professor and Head, Robotics and Automation. Then development of waveform controlled digital welding power source, programmable welding power source from my side, power electronics team. And then development of welding consumable from metallurgy. So 3 departments joined together. One is metallurgy, electrical and electronics engineering, and from Department of Robotics and Automation. So you can see what products we developed. One is for special purpose machine for pumps and motor manufacturing, because we know Coimbatore is for manufacturing of pump as well as compressor. So we did 2 automated welding, SPM 1 and 2, to meet the requirement of pump industry and compressor industry. Then 6-axis articulated robot, we developed our own, so which helps us to understand the gap in robot system manufacturing. Then based on that experience, we moved to phase 2. I will brief later on. So we did this 6-axis articulate robot by getting systems from outsourcing. For example, servo motor, servo amplifier, robot controller. We didn't have that time, but we could design and appropriately we could get it from outside and we could integrate. So that was a little costly compared to that company like who are manufacturing robots, so which could not be affordable for the small scale and MSME industries. Then intelligent welding power source, we did some modular type, so that even with a battery bank with a back on the shoulder, he can move to any place and he can weld it for a short period. That kind of modular type we made. That could be assembled in a higher side, adding 2 or 3 modules, you can use it for higher power source welding. Then welding rods we manufacture with the different composition. Then additional outcomes of that center apart from that products are we have 2 testing machines for how to test the electrodes, because when you buy electrode from some manufacturer, when you start to weld, it has some disadvantages on life, on its characteristic. So how to test that, we made a programmable machine so that you can adjust all feed rate as well as the gap, arc gap, current. So by controlling all the parameters, how it affects, that kind of machine we have. Then Cartesian robot for 5-axis we made, and also electro development furnace and other things we developed. So this is about machines what we have developed. For example, SPM1 which you are seeing is an automated assembly line for submersible pump. SPM2 is for compressor head cylinder, LPG cylinder. On both ends you can weld it, and 6-axis robot 1 and 2. These are the few pictures that you can see. Then electrode testing machine and some other robot what you are seeing, this one. So this what we did with our own technologies. And apart from that, we created some facilities to provide support to the industries. So those robots are from ABB and other gantry welding machine and Indian robots, so universal robot. So these robots from leading industries and to indigenous robot which are available inside the country helps us how to integrate this with existing program, how to do a programming, and also how to provide a solution for the local industry requirement. So few industries are always approaching us and they are doing the welding job in our center of excellence, so that they will get a support, technological support from us. This is one. And apart from this, we are also conducting a training programs for robotic programming, robotic welding, and PLC, integrated automation, SCADA, and also power electronics, and motor design. For example, 2-wheeler, 3-wheeler, 4-wheeler, we are doing for PMSM motor, BLDC motor, and also induction motor with higher efficiency. So we are providing design support as well as we are conducting a training program, so which will help MSMEs and SMEs to start up their business and to proceed further. And we did a re-engineering also, because some of our SMEs, they are buying motor from China for hub motor, 2-wheeler, 3-wheeler, 4-wheeler, and they want to understand what technology behind that, how to crack it, and they want to understand why these materials are provided at this place. So they need some fundamental engineering behind that. So we are doing re-engineering, giving training to them. So these are the other activities of phase 1 what is going on. So with this positive note, and Ministry of Heavy Industry sanctioned and second phase based upon the experience of first one. I said in the beginning, the experience what we faced when we bought some robot and integrate here. Because of non-availability of servo motor, servo amplifier, robot controller, when you buy from other companies, leading industries from abroad, the total cost of the robot is so high. So we could not match the price. So we thought that we have to develop an indigenous robot controller, CNC controller, servo amplifier, servo motor. So in phase 2, we divided the system of robot into several subsystem, and we started to develop an indigenous subsystem model. The first one is, it is for a robot controller for welding application. Since our first phase is robot welding, we thought we'll do for a robot controller for a welding application, but we know that all our XY coordinate movement. So once you know position and velocity control with the robot kinematics and dynamics, we can use it for any application. So even though the name is for robot controller for welding, but it is going to be a generic controller. It can be used for any application of robot. And we are going to use a ROS. So ROS is a open source software. So by using open source software and also firmware and hardware, you can see we are going to develop. And why welding process unit we took? Because we gained some experience with our engineers and with our faculty member, those experienced in phase 1. So they know well about what are the parameter and specifications and also control parameters required for robot. That was the reason we have chosen like that. This is the overall system. It is almost 40% of technological development is over. This project was sanctioned by MHI in 23 June. And the next one is, as I told earlier, it is a high power density servo motor. And we benchmarked companies like Kohlmarken, Maxon, Fanuc. So those are the servo motor leading companies used in CNC machine, used in robot application. And Kohlmarken and Maxon, those small tiny servo motors are much used in biomedical scanning unit also. Like even the biomedical industries in hospitals, robots are used for invasive surgery. So surgery robot, they are using those kind of motor which has high power density. So these are some of the servo motor design we have started. And our industry partner is Chakradhara Aerospace Limited, Coimbatore. They are making motors for ISRO. So why we took this is since so far for ISRO motors are being imported from, as I said earlier, Kohlmarken, Maxon. We did alternate for that. Earlier. So Chakradhara approached us for design support. We did that, manufactured, and it was successfully installed in ISRO satellite. So based on that experience, we thought we can move to the industry also. And Chakradhara is a part of LMW. So they are making CNC machine. So we thought that this machine, motor and drive will go to the CNC machines of LMW. So, but this is an open technology. Anybody in MSMEs can approach us for helping them. Then another is open source CNC system for some special purpose machine. Since robot controller and servo motor is a part of our CNC machine, we thought with the G code and M code, some small addition in the firmware in front end, we can provide a CNC system is also for our special purpose machine. So that we are planning to go for Linux based because other programming modules is proprietary item, some cost is high, it is not a perpetual license, we have to buy a license for every machine. So we thought we will go for open source, so it is a Linux based. So Linux based controller, it is a kind of a small PC, then which can be integrated to our existing PLCs. We know different kind of PLCs are available. So we want to give an open architecture. So depends upon the MSME requirement. They can choose Omron or they can choose Siemens, Rockwell, ABB, any PLC they can choose. But our CNC system should capable to communicate to those PLCs and to do the required specific job. So that is the purpose of our this open source CNC system. This is another technology. And next one is IoT system because now people are talking about everywhere digital industry, industry 4.0. But honestly speaking, whatever the machine you have, and you could see in old films that we used Pura in which will carry the communication and it will share across the borders of the country in King's time. So same thing now, whatever the existing machine, we have to attach a data module. So communication module. Of course, there are communication modules up to EtherCAT, which is for 5G, which is the fastest communication module available, architecture available right of now. So now we want to create some system which could be integrated to the existing machine. We can't ask SME, MSME, you buy new machine which will embedded with the controller for IoT enabled. We can't ask that. So what we thought in any machine, if we put our IoT device in that, with a framework. So that IoT device should compatible to communicate with any kind of network available across the globe. So that was the reason. And right now we are planning to implement that one in one of motor manufacturing industry in Coimbatore, because you can see more number of MSME, SME in Coimbatore belongs to motor. And it has several parts, several machines, and it is being manufactured with different vendor locations. So if we could integrate all those with a different location, then it would be easy for doing for automotive industry or any other foundry, because most of them are located at in the same location. So that's what this IoT system development. Then this one is again from the experience of phase 1. Because phase 1 we made a complete assembly for submersible welding. Then small industries told, so we are not for complete assembly automation. We need a small unit at affordable cost within 3 to 4 lakhs, which we have to use it for welding. So that's what we gone for a different welding machine. It is only for rotor bar welding. In submersible as well as induction motor, getting a talent welding labor is a tedious job now, and also quality. So to make that with the PLC integrated, so this is going to be such one special purpose welding machine we are making in PSG itself. Then next technology is very much upcoming technology. So it is not right now we have in this country both additive and subtractive. People have a additive machine. So here a laser layer by layer, a thickness of 20 micron layer, which will be deposited. So like that, if you make 5 layers, 20 micron, so 100 micron, then immediately we have a CNC head which will do a milling, so that you will get a finishing. That is called subtractive. So additive and subtractive in a same machine. So this machine is with our industry partner Intech Solution in Bangalore. We have collaborated, which is going to have a different hardware subsystem like laser bed system for making a powder fed. That to create a 20 micron layer by melting a powder, any metal powder, you melt it, and for a given CAD profile, you can deposit for a thickness of 20 micron. That is with a selective laser. Then if you do it for 40 micron or 100 micron, that depends upon the precision of requirement. We will go with the CNC milling program, which will do a machining, so that we will get a smooth profile and also the material characteristic. And this is about optic module, which will also do a feedback system for controlling our CNC system. Then we have a software, our own software for data preparation, like different material, different profile needs different wavelength, laser power, feed rent. So all those control parameters could be controlled using a data software. The issue is now industries are asking a ready-made program, like how people in software moved from C, C++, then Python. Now people are moving for Julio. So that there is no need of spending much time, and we don't need any talented people. A ready-made block, pick and put it and start to use. So similar kind of material library we want to develop with a great exposure of our industry partner Intech Solutions. They are going to give their field experience, and our software engineers will develop a software program. It is going to be a library. Just you click, select the type of material, select the type of process, so it will automatically choose the control parameter, and it will assign what should be the laser power, what should be the feed rate, what should be the current. Every control parameter will be assigned automatically. Maybe a fine tuning is required from the industry quality system based on that. So this is our next technology. And the last technology is on laser cladding. It is pure on our metallurgy aspect. So it is when you give a CAD drawing and some for welding material as well as other material, we have to make a cladding. So that cladding is going to be done with a laser. So it is kind of a repair of existing one and creating a new to avoid breakdown of a material. So these are the technologies that we are going to develop. So these are the outcome which from the MHI sponsored project given to us, and which will be useful for the industries. So thanks for EEPC for giving this time and to share our development to the industry media, which will be useful for you, and as well as your experience, your problem will help us definitely for learning us. So we welcome you all to PSG whenever you need. We have a contact, you can contact. So we are ready to support. So thanks for EEPC and team. So any queries from audience? Yes, sir. Madam, Q&A session. Okay, thank you.
Dr. Sundaram, thank you so much for your address, and I'd just like to brief the audience that the presentation copies will be shared with them, so you can have a look at the relevance for your industry at your leisure also, and please interact with the speakers during the Q&A round. Mr. Arun Kumar Garodia, Chairman EEPC, has joined us, and I request Mr. Garodia to kindly welcome the audience and the speakers.
Good morning, friends. A very warm welcome to all the enterprising MSMEs joining this session on automation and smart manufacturing. I welcome everyone from PSG College also, and so many booths have been set up by you all. So I really welcome you all this morning. This session is being organized with the 11th edition of International Engineering Sourcing Show, IESS, which is India's biggest platform for international sourcing opportunities for engineering MSMEs. The 3-day event has invited over 300 international buyers for exploring sourcing opportunities from Indian MSMEs. Besides, series of sourcing and vendor development programs and showcase by over 300 exhibitors across the engineering supply chain and technology providers. This session, supported by the visionary Ministry of Heavy Industries, Government of India, marks a significant step towards empowering our MSME sector with cutting-edge technologies. As we know, MSMEs are the backbone of our economy, contributing significantly to employment, innovation, and overall growth. However, navigating the path towards growth and competitiveness in an increasingly digitalized world requires embracing automation and smart manufacturing solutions. This session aims to equip you with the knowledge and tools to embark on this smart journey. Understanding the benefits of automation and smart manufacturing towards enhancing your productivity, efficiency, and product quality. Identifying suitable solutions for your businesses by exploring range of automation and smart solutions tailored specifically to the needs of MSMEs across various industries and scales. Learning from expert insights from renowned speakers and industry. Gain valuable insights into the financial assistance and infrastructure development initiatives offered by the Ministry of Heavy Industries, propelling your journey towards automation and smart manufacturing. With sincere gratitude to the Ministry of Heavy Industries, Government of India, and our esteemed speakers here, I welcome you to this enriching session. We encourage your active participation. I am glad that EEPC India is deeply committed to facilitating this exchange of ideas, sustainability in a big way. In fact, the theme of 3-day IESS this time is aptly named Sustainable Smart Engineering. We believe that this meet will foster partnerships that not only benefit individual companies, but also contribute to a greener and more efficient future for all of us. I extend my heartfelt thanks to all our eminent speakers who have spared their valuable time to address us here today. I am thankful to all the dignitaries and guests from audience who have joined us here to make this session fruitful and productive. I am thankful to Team EEPC India for organizing this valuable platform. I wish all the very best and a fruitful session ahead. Thank you so much, sir.
Chairman, sir, thank you for your encouraging words. With this, we now invite our next speaker, Mr. Gopi Krishnan, Scientist D and Group Head, Precision Machines and Aggregators, CMTI. Sir, over to you for your presentation.
Thank you all. Good morning. My name is Gopi Krishna. I thank EEPC India for organizing this wonderful event at Coimbatore. And I thank EEPC again for having CMTA and myself here for this event. Myself, Gopi Krishna, I'm working in CMTA for past 15 years here. I'm basically specialized in the product developmental activities at CMTA related to precision engineering domain. My fellow group is also working on smart manufacturing technology here at CMTA. So I'll be presenting the smart manufacturing activities, what is going on in CMTA, and how MSME can benefit from CMTA in these activities. Okay, next slide. Okay, to just give a brief about CMTA, many people will be knowing about CMTA, but to just give a touch upon CMTA. CMTA is basically Central Manufacturing Technology Institute, which is set up at 1960. It's a government-funded R&D institute. Right now, we are under Ministry of Heavy Industries. So in 1960, we were pioneered to set up the CNC-based technologies in the country. So along with HMT, CMT also was working on the development of CNC technologies for the country, and we were transferring the technologies to the industries in 1960s. Later, as the technology advanced, we also started working on. Later, as the technology advanced, we also started working on. We also started working on the NC technologies, the fluid power technologies and all that. Later in the 80s, we started working on CAD-CAM and all that technologies. Later, we started working on the computer integrated manufacturing. As the technology kept advancing, we also started taking up the new avenues. So as the technology keep advancing, we also started working in nano manufacturing technology, additive manufacturing, sensors and vision technology, and right now we have also taken up the smart manufacturing technology. So where we try to develop the technologies and we transfer the technology to industries for mass production. Okay. So CMTA's strength is basically on the product developmental activities, and also the internal R&D, which is futuristic technologies what we work for. And we also have multiple lab services at CMTA, like metrology, dimensional metrology, calibration labs, the metallurgical labs, the noise and vibration facilities and all that. Where the industries cannot afford to have such facilities, they can get the services from CMTA. Okay. And also we work on the human resource development at CMTA, where we conduct a lot of training programs for industry participants. On smart manufacturing also we conduct. So this is basically for the practicing engineers to upgrade their skills and also to upgrade their skills and work on the field. Okay. So coming to the topic smart manufacturing, many distinguished delegates may be already knowing about the smart manufacturing technology, but I just wanted to put 1 or 2 slides to give a brief about what is smart manufacturing and Industry 4.0 to audience who are new to the field. So we all know industry revolutions have happened. What is Industry 4.0 is basically the industry has revolutionized in multiple sectors. So in Industry 1.0, what happened is we started automating, not automation, it is basically the invention of machines. where not even electrical power was there. We were powering the machines using steam power and coal power. Okay, this is basically the Industry 1.0 revolution. And later in the 19th century, Industry 2.0 started, where we had automations in the range like conveyors and all that, where the biggest industrial revolutions happened. But with the those times where electricity was also there, using that we were able to scale up the production. But here there was not like a closed loop systems. The machines may, the man makes most of the decisions here. Okay. So in Industry 3.0, what happened is we tried to make a closed loop system. Okay, the machines we try to put sensors, feedback systems, and all that, and try to control the machine altogether. Okay, so but it was limited within the machine. Okay, so in Industry 4.0, what we are targeting is already the Industry 4.0 is something not. It all depends on the previous strengths what we have developed all these years. Okay, it goes with the strength of Industry 3.0. Added to that, we are trying to implement the other technologies also into it, so that we can make the machines more smarter, the shop floor more smarter, so that the machines can be connected through internet, and you can monitor the shop floor anywhere across the world. Okay, earlier it was not possible in Industry 3.0. Now we are also trying to bring internet into things, and also the IT sectors are also grown a lot. So those technologies also we are bringing into it, and how these manufacturing field can be automated here. So that is Industry 4.0. So these are basically the the technological advancements which has happened. The big data analytics, the cloud, cyber security, the industrial Internet of Things, these are all basically which has happened in the IT revolutions. Okay, so now the technologies are more merging. Okay, so these advancements, whatever happened in the IT sector, also we are trying to pull it into the manufacturing sector, so that we can try to work on those strengths. Okay, so the smart manufacturing is nothing, it's not a technology alone, it is basically a marriage of so many technologies which has grown up. So using that, how we are empowering the manufacturing sector. Okay. So as I was telling earlier sector, you can see that the cyber physical system is nothing but the man, machine and sensors, which was which has been developed in Industry 3.0. Okay. Now what we are doing, we are trying to, we already have sensors, devices, all that in the Industry 3.0 itself. Okay. Now in Industry 4.0, what we are trying to do is, we try to take this data, the available data, and take it to the internet, so that data analytics can be done, and we try to get a better efficient outputs from the data. Okay, using this we can connect all the machines, we can talk to each machines, and we can also send the data to the cloud, so that the factory can be better efficiently managed. Okay. So there are other technologies which are evolved in the electronics and communication side, and also in the IT sectors, are all being looped into a single platform, which is the Industry 4.0. Okay. So okay, what are the benefits is basically all are aware that we get a good product quality, the reduction in cost, and also the increase in productivity. The reduction in the cost, basically the initial investments may be little higher, but if you see the return of investment, you will be able to get the investments faster. And also we have a higher efficiency in implementing the smart manufacturing. Okay, now for implementing these smart manufacturing concept in MSME, there are multiple challenges, right? For a multinational companies, it is very easy because of the higher investment capital what they have, they can implement it. But the challenges what MSME faces in implementing this, we have just tried to highlight it. Basically, all the MSME industries, many are operating in the Industry 2.0 and 3.0 range. Okay, how to convert these machines into a ready for Industry 4.0 is a bigger challenge here. and high volume of legacy machines. Legacy machines in the sense we have what we call is the old generation machines which doesn't have machine connectivity. Okay, nowadays new CNC machines have machine to machine connectivity protocols are there, but the older generation machines which cannot be connected to cloud phase. So how we tackle those problems also we are trying to address in our developments. And it is also requires a very high initial investment cost for setting up all the smart manufacturing and all that. For that also we are trying to work out some solutions for MSME industries also. So all these issues we are trying to address at CMTI. So on this basis, the Ministry of Heavy Industries has set up common engineering facility centers across the country. It is basically set up at IIT Delhi, IIT Kharagpur, C4I4 at Pune, and CMTI and IASC. So these are something like 5 Samarth centers called smart, working on the smart manufacturing facility. These are called basically common engineering facility centers, and any MSME or any academic institutes also can collaborate with all these 5 institutes to work on smart manufacturing area. These are set up by Ministry of Heavy Industries. So at CMTI, our center is called Smart Manufacturing Demo and Development Cell. So what we are doing is we are trying to develop solutions, cost-effective solutions which can be implemented at MSME industries. And also we have partnered with multiple MNCs and also small-scale industries and also PSU sectors and academic institutes. We don't want to leave anybody in the evolution process. So we are trying to partner with even small-scale industries which has only 2-3 machines factory. So we want to understand all the challenges in different sectors and how we can implement these technologies. So that way we have strategically partnered with multiple industries. And we also developed a smart factory at CMTI where you can come and visit us to see how a smart factory really works. We are also working on sponsored projects and R&D developments, which I'll be covering in the talk. And not least, we also work on training and awareness programs. One is working on the technology, and the other side, the man skill needs to be developed for the country. Though we implement all this in the industries, the people should be able to work on that. So that way we also give training programs at CMTA so that the industry participants, they come, get trained, and they start adopting it in this one. And also we try to implement in college levels also, so that the students who pass out from the colleges, they'll be industry ready engineers to adopt these technologies. Okay. So these are the some of the partners which we have linked with. HAL, Akumac is a MSME company who are working in spindle developments, and Siemens is a multinational company. IMTMA is a machine tool association. Hexagon is again an MNC company. Utunga Technologies is a software company who is purely working in software developments. So we are trying to include the IT sector industries also, so that how they can link with the sectors. Okay, these are the major projects which we have taken with variant companies. With Siemens, we are trying to work on digital twin technologies, which are the new evolving area in smart manufacturing. With HAL, we have set up experimental learning labs. Multiple labs have been set up at CMTA for the training purpose. With Hexagon, we have set up the smart and digital factory at CMTA, which you can come and have a look there. With IMTMA is basically a machine tool association. Through them, we get connected to multiple machine tool sector industries to understand their problems and how we can deliver solutions to them. With Utunga is basically a IT-based company, but with them we are partnering to develop solutions for the manufacturing industries. Okay, so this way we have taken up multiple projects. And I'll just touch upon the brief this one. So this is the smart factory what we have set up at CMTI. See, smart factory is basically many of the tools the machines were there earlier, the robots were there earlier, but the missing thing is all don't talk to each other. In the earlier scenario, in the industry 3.0. Now in industry 4.0, what we are trying to do is, we are trying to make the connections between all the machines, okay, through Ethercat and other communication protocols are there, where we link all the machines and the robots and also the metrology machines also will be connected. And all the machines can be monitored through a central console. Okay, this will be kept separately from the shop floor, where a master controller can control all the things. He can load the CAD model to the machines from the control station, and he can also monitor how the machines are happening. Machining is happening, what is the cycle time, what is the productivity cycles, everything can be monitored. It is a single control station. Okay, and the same data can be taken to cloud. Even CMTA data we have put in cloud. Anybody across the global, they can open the CMTA, we have a login, this one, and you can check what is the productivity is happening at CMTA. What is, I mean, the smart factory what we have set up, how whether the machines is on or off. Even though I'm in Coimbatore, I can check whether my shop floor is working in real time. Okay. So this is the smart factory we set up, and these are the training facility what we have created. The collaborative robots laboratory, the mechatronics laboratory, industrial automation, smart metrology, AR/VR laboratory, CNC controller, fluid power, smart condition monitoring. Actually, these are the supporting technologies for smart industry 4.0. So only talking on the industry 4.0 will not help. So we want the practicing engineers to understand the fundamentals also. Using that, how they can take up to the next level. So we give training on all this labs also, so that they can get. So it all becomes building blocks for development of these things. So we conduct extensive training programs at CMTA for smart industry 4.0. So these are basically our, as of now, we have trained more than 1,000 plus participants through webinars, seminars, and also the training program, in-house training programs, hands-on training programs and all that at CMTA. We have also taken up industrial projects, as I told. Those things also we are working on. I'll just cover up on, so this is the website I was talking about, cmta-iiot.online. So where if you go to that website, you can see what all machines are working currently at SMDDC facility what we have, and what has happened morning to evening, and all that can be seen there. If the machines is off also, you will come to know. Okay, so some of the success stories or contributions what we have done for the sectors, I'll just briefly touch upon. So the first challenge I was talking about, right, like the legacy machines. These machines are the older generation machine which doesn't have any smart features or any machine-to-machine connectivity. So in these machines, what we are trying to do is, though we want to bring these machines also into the smart ecosystem, is we try to put external sensors. We put a temperature sensor, we put an accelerometer and all that, and we monitor the process. Okay, in case if their spindle vibration is more, we put an accelerometer on the spindle, we monitor the spindle. It gives alert. We put a threshold. If there is a if the vibration is more, we have to change for the bearings and all that. So these machines, it is like a breakdown maintenance. When machine goes into fault, the people come, they check what has happened and they change it. Here what we are trying to do is we put the sensors all into it so that we can real-time monitor the machine. Okay, so though it is an old generation machine, we are trying to put external sensors, and we have developed dashboards also for these machines. So though these are old generation machines, we put a dashboard and we can take this data also into the cloud. So if there is a factory which has 50 plus machines and the 40 are new generation machines and 20 are old generation machines, even those old generation machines data also can be taken to cloud using these technologies. So this also we have worked at, and this we have tried on 3D printers also. And these are very, very cost-effective solutions. I'll talk about the cost also, what we have developed. So in this, we try to develop a smart, energy monitoring devices for those machines I was telling, right? See, these modules we were, in fact, we gave to an industry. Whatever we develop, we don't want to keep with us. We wanted to try out in industry framework also. So we gave to a small-scale industry, high-tech precision at Bangalore. So we offered a solution, something like on no cost, no profit basis. We offered a solution for each machine to make it into a smart machine. We offered a solution somewhere around 4K to 5K, 5,000. So overall, we offered a package something around 30 to 40,000 with all the framework. so that he can take the data to cloud, he can monitor the machine, everything. This was like a use case study we also wanted to see, because the small scale industry, they will not be able to afford very high end solutions. So that's why we try to give a low end solutions so that they will have the feel of that. So, and also they can give now because of the advancements in MNCs, they also want their vendor MSME industries to be smart. So that they can also track the data, what is happening in their vendor place also. So that way many industries come to us for converting their machines, I mean their factories into smart. So in that case, we cannot ask them to go for advanced machines where it can have machine to machine connectivity and all that. So in that basis, we try to give the small scale solutions. And again, if there are 100 industries approaches us for manufacturing all this, we will not be in a position to do that. So that way, we offer these technologies also to a small scale industries who can take this as a business. They can approach us, we give the technology to them, how to develop these modules, how to integrate them, all the set of documents, everything we give as a technology licensing. They can take up and they can implement it. They become integrators, or they become the business providers for such solutions. So those people also, with these technologies, we have transferred to many companies also. This is one more machine, one more module what we developed is machine tool condition monitoring. See, the initial point what I was talking is basically we are talking about the productivity of the machine, okay? And here we are trying to monitor the health of the machine, and also it will help in condition monitoring of the machine, and also predictive maintenance and all that can be done using that. So these modules also has been developed by CMTI, indigenously we have developed. We created a dashboard also. These modules also we have integrated in many factories. I'll show in the further things. And this technology, as I was talking about, these technologies we transfer to AMS India, which is there in Bangalore. They are basically OEM milling machine manufacturers. So we are transferred the technology. They are trying to implement to their customers who has older generation machines. Okay. So that way also we are working. And this is one project which we have taken with Akumac. Akumac is basically a spindle manufacturer for grinding machines. So here, see, as he is a OEM for spindle manufacturer, now because of the advancements, many machine builders, they want their spindles to be smart spindles. So where they can get the data output and all that. So automatically, he has to spend a lot of efforts to develop his spindle also to smart compatible. So in that case, he has partnered with us. Where we are trying to integrate multiple sensors into the spindle. We have taken the design of the spindle from Akumac, and we are trying to integrate the additional sensors like force sensor, vibration sensor, temperature sensors and all that. So all the data can be sent to the cloud. So once the products, the Akumac spindles become smart, automatically you can cater to a higher end OEMs where they can take the smart spindles as a part of it. Okay. Okay. See, and again, for taking the data to cloud and all that, there are established products are there, which are costly solutions are there. But in-house, we are trying to develop this the gateway IoT edge devices, which basically collects the sensors data and push it to the cloud. Basically, if we try to connect all the sensors data directly to the cloud, what happens is there will be a latency. There will be a time delay in collecting the data. So here, yeah, sure, fine. I'll wind up faster. So the edge device is also it's basically a building block for smart manufacturing devices. So these developments are also we are indigenously developing at CMTI, and we are also working in AR VR systems which will help for machine maintenance, and also will aid the operator in real time what he has to do, what has to be done in case of maintenance or something. The maintenance team can be sitting at abroad or somewhere, and the operator who is there at the factory can be guided through virtual reality and how it can be corrected. So all this can be, all this are being developed. We also develop dashboards for overall effectiveness of the shop floor and all that. As I was telling, process monitoring also modules we are developing, which all these modules, whatever we are developing, no, the technologies is available. The technology also can be taken up by industries from us and can be done for mass production. And along with Siemens, we are working on digital twin technology, where we are trying to develop a real simulation, what is happening in the real case in the machine. The same can be seen in a CAD model. Okay. Earlier, the CAD models and the machine will be totally separate entity. It will not be connected. But here, whatever is happening real in the machine can be seen in a 3D model. If the fluid is, the chiller is on, all that can be seen in your this one. How the flow is happening, everything can be seen. This is basically the advancement in digital twin, and that factor also we are working. And this is the setup what we have developed. We are also working on, there are nowadays Bluetooth devices are there in your vernier caliper and all that. So we are also working on softwares which can directly collect the data from these Bluetooth devices, which can be taken to the cloud. There are established softwares are also there, but we are trying to develop low-cost solutions for small-scale industries. And this is one case study which we gave to a small MSME industry, where they have multiple welding machines. Okay, if you see their factory, it is a very small scale industry where they were doing welding for metro work and all that. The problem what they faced is they were trying to do welding, but the operators, they were increasing the voltage and they were doing it faster, so which was leading to low quality issues and all that. So what the industry owner, they wanted us to monitor the systems. So though these machines, the welding machines, those are not very high-end machines, we try to monitor the voltage, we try to put a voltage control and all that from the machine controller. We try to give a very low-cost solution. Even the data, so the operator, whatever they do, it will get logged into the data. And the same thing can be taken to cloud. So these are all very low-cost solutions which we gave to MSME industries. So people should not think like smart manufacturing is a very high-end cost-consuming project or something like that. But it is, as the technology is evolving, all this can be adopted in MSME industries also. So this is the module, as I told, small scale industry, where they have implemented, and the shop floor in charge can monitor whether the machines are on or not in the third shift, where he goes home. He may not be able to monitor whether really their people are working or not. All that can be monitored at home from his mobile dashboard. And not only small scale industry, we worked with Toyota also. The Toyota engine plant, what we did is they had 65 plus machines. Okay, Toyota, it's a leading global this one. So with them also we implemented our solutions, where we try to monitor each and every machine. They identified some 17 parameters what has to be identified for each machine. Though their maintenance team was doing manually, they were not able to get a real-time data. So in that we try to get all the data. With this, it's over. Get all the data from each machine, whether of all the 17 parameters from each machine. Okay, so when we are implementing this itself, they were able to find out so many faults which is there. The vibration was in some machines were more, the temperature was rising because of the bearing issues and all that. So when we are implementing itself, they were able to get benefit out of it. And later, once we implemented, now all this data, they monitor this one, and the same data is sent to Japan also, so that the Japanese team can monitor what is happening in the Bangalore plant, what is the engine production is happening. And these are the other this ones which we are working. See, we are also working in high-end precision machine tool developments also. So where all these times, so I was talking about the health and also monitoring technologies and all that. But using that, we can also try to improve the machine accuracies. See, already you have a machine, it has accuracy, but how to get the best accuracy from that? So the smart technologies, we try to integrate multiple sensors to the machine, where we try to monitor the real-time geometrical errors in the machine and how to correct that in real time also. See, in case the blue color is the error positions of the machine. So how we are correcting it after the implementation of the smart modules, how the error bands have been corrected. in different, the pitch, yaw, straightness and all that. The geometrical accuracies of the machine also can be improved using this technology. So these are the next generation, I mean the futuristic things which we are working on that. Now many people have not started working on these aspects. Now we are trying to monitor the workshops, everything. But futuristic, we have to work on the improvement of the available machines also to get higher productivity. So those things, aspects also we are working. And that's it. It is basically how CMTA can work with, how MSME can get benefit from CMTA is they can collaborate with us for any developments or for integration of their products, and also they can bring their systems and get it tested at CMTA. And also we provide hands-on training programs and all that for industry partners, so that they can get awareness and also get exposed to CMTA technologies. Thank you. Thank you for giving the opportunity.
Thank you, sir. Thank you for your valuable address and for highlighting some of the very insightful success stories. Due to paucity of time, I would have to request the next speakers to kindly be a little precise with their presentation. And I now invite Mr. S. Sunil Kumar, Head Application Systems and Solutions Genetics India Private Limited. He is representing also the Automation Industry Association.
Yeah. Yes. So very good afternoon to all the gentlemen, ladies and gentlemen present here. So first of all, I would like to thank EEPC and Automation Industry Association for giving me this opportunity. So I represent company Genetics India Private Limited, which is located in Coimbatore, the manufacturer of pneumatic products and systems in India. So I take care of solutions where systems related to automation and solutions related to automation, soft floor, all those things that I come. So this is about the agenda that I'll be just talking about introduction to genetics and AAA. So genetics was founded in 1977. So we as a group companies, we are into automation product manufacturing. So we have established Skyfast and Genetics Industrial Automation, various group companies for the operational reasons. So we focus on complete automation solutions. So close to 2,000 employees are present here. So why I should present about AA? There is a correlation. So we are associated with AA, that is Automation Industry Association. We are partnered with them in 2019. So just to give a brief about AA. So AA as a association comes under Ministry of Heavy Industries, founded in 2004 by the apex body for automation industry, pioneered vendor neutral approach in developing educational curriculum for universities, then promoting industry practice and skills consonant with the global standards. Then about 2/3 of the variety of industrial use cases are with our members. The AAA is not only with the group of people, it's more of a industry association where the industry people are joined hands together to support in the society. So AAA members represent technologies across the full spectrum of industrial automation and digitalization. So it includes all the technologies like electrical, mechanical, circuits, everything. So they are the core members. So Mr. Anup Wadhwa is the director at Automation Industry Association. Then executive councils from various industries, Mitsubishi, then Accent, then Pepperfox. So these are the AA members. So AA is a group of association that we understand. So let me just move on to the current scenario of the industry. So the increase in global acceptance of products from India, because now you can understand the potential of the manufacturers, those who are investing. So there are people expecting India to make the products indigenously in India and export for the other countries, as well as to support the Indian manufacturers. So generally the automation, where we were understanding initially in the late 90s and some time back, we were understanding automation is for only the machines, robotization, expensive solutions, reduction of labor leads to unemployments. But this all now goes behind. Now we are focusing on the technologies and how we can improve the productivity, quality. So the actual fact of the automation is it enables the industries to improve their productivity, quality, and to identify the predictive failures, what could happen, what can stop their machines, all those things. Then the low cost automation. So the automation not necessarily be the high-end automation solutions. It can be a small automation which can save the human fatigue, or which can increase the productivity, or which can improve the quality. So empower human resource, where utilization of human being as a source of energy is an inefficient method for boring and monotonous work. So for giving the better dignified role to the human beings, this automation could be implemented. So using an operator as a sensing device is not only uneconomical, but also would result in excessive fatigue. So these are the general aim of automation: to increase productivity, product quality, necessity of skilled workforce, effective utilization of resources, to improve worker safety, to reduce manufacturing lead time, removal of monotony to labor. Not for the removal of labor. So this is the general structure of automation, where you can see the field level of components. We talk about sensors, actuators, then goes to the controller, that is PLC, HMI. Then subsequently it is being taken to SCADA, DCS for the monitoring. Then MES, manufacturing execution system, then ERP. So this is the current automation structure which we were following till 3.0, that is Industry Revolution 3.0. So what we expect, where we are transforming, is towards 4.0 and 5.0. Now we are not terming anything related to numbers, it is just X. So we are moving towards the excellence. So the current system is now, with respect to the sensors, actuators, all within the factory, which is not connected. The previous speakers also were mentioning about these facts. So the current expectation is where this IT and OT has to be converged together, because the OT system which we are deployed in the shop floor are not connected together, not connected to the IT system, because the systems working for the produce some sort of job or work, but not connected to the machine for the data visibility. So to bring the data visibility, so the machines are connected with the internet to bring the smartness, where the data will be captured through various sensors. From that could be transferred to the cloud. And the IT system will support in collaborating the horizontal and vertical integration between the factories. And the enterprises IT also could be part to establish this structure of 4.0. So this is the transformation that we expect from existing to 4.0. So these are the key important building blocks. Though we talk about automation and smart manufacturing, Industry 4.0, these are the concept, or I would say it's a more of a framework which includes various technologies integrated. So here the simulation, system integration, Internet of Things, cyber security, cloud computing, additive manufacturing, augmented reality, big data, AMR. So these are the key things that comes under Industry 4.0 solutions, or the factory automation, in which there are commercial platforms like ThinkWorks, MindSphere, Zogo, IoT for the web application creations, and Internet of Things, where we need a gateway device for connecting the machine to the cloud, where there is a device from Siemens. There are many manufacturers who manufacture the gateway models, and supported by the cloud computing devices like the Amazon, Azure clouds, and augmented reality, Microsoft HoloLens for the troubleshooting purpose. So these are the integrated technologies. So to get into this smart manufacturing or Industry 4.0 concept or the framework, so automation is the foundation. So without the foundation, we cannot add layer on top of it. So first, the understanding is related to the automation. So how to identify an automation system? So to selecting the right card, that is increase the capacity to handle demand, because the global requirement is more. How are we going to improve the day-to-day, the productivity? Then where we are stuck up with the quality issues, where we are stuck up with the availability of the machines. So improving quality, effective utilization of resources, operator safety. So this is the general method followed globally. USA, that is to understand the problems first. So what could be the reason for reduced productivity? What could be the reason for reduced quality issues? What could be the reason for any failures that comes across? So we have to understand and simplify, then automate. So it's not necessary to implement any high-end automation systems. Even it could be a basic one, sort of basic pneumatic cylinders or hydraulics. Anything could be implemented to save time, to increase the productivity. That is how that starts automation. So these are the key strategies of selecting automations with respect to the specialization, combined operations, simultaneous operations, integrations, increased flexibility, improved material handling and storage, online inspection, process control and optimization, plant operation control, computer integrated manufacturing. So according to the industry needs, according to the actual MSME needs, this could be identified and implemented. So these are the three factors that generally comes in the necessity of any MSMEs. One is the online inspection, process control and optimization, plant operations control. So this is the general way of automation's migration strategy, right from the phased manner, where we can implement some sort of automation initially, the phased manner, phase 1, phase 2, phase 3, like that we can go in a complete automation solution. And the connecting to the network, where this networking of different machines involved, because the automation systems as a holistic way, if you talk, it's a multidisciplinary thing where it integrates various technologies connected to automation. It's not only limited to a mechanical device like pneumatics, hydraulics, fluid power. No, so it's a control device where electrical plays a major role in controlling the fluid power equipment, similarly the motors. And then comes the robotics, where again the robotics needs programming, PLC programming, those things. It's a totally integrated solution. So with that, I would like to just talk about a few use cases that we have implemented. So these are some of the applications where we implemented in our own factory for small improvements. So this is the kind of leak testing machine. Initially we were doing the leak testing through water dip test, where the components will be dipped into water for checking the leak test of the product. So that was time consuming and human fatigue, where the operator has to lift the component, dip it into water and replacement of water. So we were having a lot of difficulties in handling this. Then we migrated to dry leak testing. So where we have equipped the machine, the same machine where you can keep the component, based on the differential pressure mechanism, it identifies the leaks between the two chamber, and it gives the data like approved or rejected, which was a time-saving solution which we implemented about 4 years back. Then the same data is being pushed to cloud, because earlier we used to maintain a lot of papers where we maintained the reports like leak found and what is the cause, all those things. So now all those things are captured through PLC. The PLC sends the data to cloud, and we are able to monitor everything on hand, real-time data. Similarly, the assembly automation systems, where the space consuming area, this was the cell assembly. Then we simplified to cell assembly with the reduced space, with the ergonomics, safety of the operator, and which was implemented with IIoT. Again, the same testing was done by the manual thing that we automated. Then this one is the regulator FRC performance testing. Then we automated with a small motor arrangements which will adjust the regulator, because to probably people can understand the regulator which is used to control the outlet pressure. Generally it has to be adjusted clockwise and anti-clockwise to rate the pressure, outlet pressure. So for during the testing, we found a lot of time being taken to test, because while adjusting the movement of the rod, it takes more time and it was a time consuming process. Then we implemented a stepper motor for automating things. Similarly, this is another case of performance testing. And this is the AR solution that we have done for troubleshooting. So where we implemented, apart from the industry solutions, we also supply to learning equipments to institutes to teach the automation technologies. So in which we have incorporated a AR based solution for troubleshooting, where there is a machine which produces, there is a fault, it's being identified with the AR application. So that AR app itself says what is the troubleshooting method, trouble, cause, remedy, and the trouble without any skilled person, without any knowledge. Simply that app guides the person who is attending that complaint and will be able to solve that. So that is how we empower the operators to the next level of the technology. So immediately it identifies and it solves. Once that is set, then the trouble alert goes off. And this is related to MES solution that we have done in our own factory, that is Skyfast, which is a pressure die casting unit. We had difficulties, like there were communication gaps related to the orders. Though 90% of orders were done for only genetic group companies, the recent days we have taken the order for the external customers also, services, defense, ISRO. So there were communication gap that we found between order scheduling, then unpredicted breakdowns in the machineries, then machine health and process control issues, then operator and production OE issues. So for the solution, we implemented scheduling, targeting on the displayed value, and continuous monitoring, production and operation monitoring. Then finally we achieved data sharing regularized, increased in production, machine life improved, management effort reduced. So this is the dashboard that we have done for identifying the schedules, where the schedules can be entered manually by the operators, one in the central row, and also that could be altered with respect to the priorities. So any main breakdowns or any specific customers, we can do the dynamic scheduling also. And we could track the process, where initially we were struggling in identifying the components process totally, because the PDC components, which will have 1,000 numbers, 10,000 numbers quantities, we may not be knowing, only at the end of the day we'll come to know what is the percentage of quantities being produced. So now with the support of IIoT, we could track that machine performance with respect to the order quantity in every hours or every minute that we would like to understand in that data. So we'll come to know what could be the data, or what could be the productivity of that particular day in the end of the day. So that also could be predicted. Then we have even included the operator efficiency, whether the operator is really able to perform well, whether is there any skill set is required, whether the training is required. So those things also being captured in terms of operator efficiency along with the machine OEE. So while talking about this technologies, I was mentioning the automation is basic foundation. So finally, end of the day, when we talk about the machine failures, we talk about only these things. What could be the MTTF of the product? When should I service? Or when should I replace? This is a general question that comes to any maintenance person. Because one thing that at front we talk about order, automation, all those things. At the back end, when we come across the requirement of the machine availability, these are the main factors that generally everyone has required. So the importance of monitoring compressed air. So even the automation is not necessarily to be only for the productivity and quality, even for the utility monitoring. Because the utility is the one factor which consumes huge money. in terms of producing electrical power, in terms of electrical compressed air energy. So any industry that you take, generally the compressed air is being used. Mostly 80 to 90% of the machineries consumes air, compressed air for their working. So the compressed air in the energy aspect, if you see, the equipment 12%, maintenance 12%, 76% of the energy is being consumed only for this particular operations. So the compressor performance is represented as a free air delivery, that is atmospheric air conditions. Over 10 years, electricity costs 76%, while maintenance equipment shares only the 12%. So the importance to the utility also to be given. So the air is free, but compressor air is not free. So for which we have a solution provided to the industries. Even we have our own factory we have implemented with the air flow monitoring system. So where we have got the flow meters to measure the LPM, liter per minute, of the particular machine's air consumptions. With the abnormal limit, it will give an alert so that people can understand is there any leakage in the systems. So that way we can do the energy saving. So this is the dashboard just for the glance. So this is the just a comparison of energy saving cost with respect to one case study that we have taken. So you can look at, this is the data taken from the tire industries. So where there are number of machines lined up with 1 to 6 and actual air consumption and after online monitoring, because initially this was not implemented because you can't predict each and every lines where it leaks. So while using the flow meter and the energy saving method, so we were able to identify that leakages, which was directly related to the air savings in terms of CFM, which is supposed to be consumed this much, but the actual saving is 45 CFM. So for the understanding of the cost to produce 45, the previous case what you have seen, it's related to the 45 CFM required 12.9 HP compressor to produce that much of air. For 1 HP is 746. With respect to that, if you calculate, it comes close to 9.65 kilowatt hours. Considering 8 rupees per kilowatt hour, you can save 6.6 lakhs per annum. So this is just one case study that we have taken from the tire industry. Similarly, for any industries, this is a normal case where people should know about their amount of cost is spent. So in terms of so the charity starts from home. Similar way, how we are energy efficient in home, the similar way in the manufacturing industry also should look at the possibilities of reducing the energy so that we can save a cost in terms of compressed air and electricity power. So a small video about that solution. So there is a flow meter connected to the airline, and that is connected to the slave device, wireless device, which talks to the master model. So in the textile industries, you can see the number of machines connected to the flow meter. From there, the data is going to the master device, where the supervisor can look at the data, how the machine data, air consumption is. So those data are passed to the cloud. You can generate shift generation, communication to maintenance team for alerting the leakages. So it is available in desktop application, web application, mobile app. So the context of new skills, yes, like I mentioned before, apart from the industry solutions, we are also actively involved in providing training to industries as well as academia in teaching the latest technologies. So other than that, the support objectives, so Automation Industry Association aims to the platform of choice for the Indian industry to connect and exchange knowledge inputs related to automation, Internet of Things, robotics, increased knowledge and awareness levels about the role of automation in its value proposition, help Indian industry leverage cutting-edge automation technologies and be globally competitive. So enhance top management sensitivity to benefits integrated automation solution, build synergy amongst industry researchers, policymakers and users, attract fresh talent to careers in automation. So we are working closely with academia, engineering colleges, where we are connected to various technology partners like Mitsubishi, Omron, PTC, and the knowledge partners like IIT Delhi, AEA, Foundation for Smart Manufacturing. So we connect, we being in this industry for more than 40 years, we connect all these industry partners. We wanted to be an industry partner to transfer the knowledge to them. So these are some of the awareness programs that we do in collaboration with the AEA. So AEA has recently conducted automation for smart manufacturing events. So the learning workshops. So that's about AEA initiatives. So thank you all. Thanks for your time. Thanks for this opportunity.
Thank you, sir. Thank you for the presentation and for highlighting the various initiatives being undertaken by Janetics and AIA for strengthening the industry's connection to automation and smart manufacturing. Unfortunately, we have to vacate this hall for the next session at 1 p.m. sharp, and that is why I request our next speakers to kindly be brief in their presentations. I invite the next speaker, Mr. Abhishek Pandey, Senior Manager, Digital Industry, Siemens Limited.
Good afternoon all, and as ma'am said, we are running short of time, so I'll be very crisp. My 50% of the presentation is already been done by my fellow speakers. Okay, so I'll be very much in short. I will explain how to embrace Industry 4.0. Okay. I think Mr. Gopi Krishna had shown the challenges and MSME will be facing to adapt to Industry 4.0. So there are certain ways. It is not only cloud the only solution, but we look at the options that we can adapt for embracing Industry 4.0. So couple of slides. These are the current trends in the current manufacturing industry. So we have to increase the efficiency and the productivity. The markets are volatile, so the demands are very much fluctuating. Okay, maybe after COVID we see there is a sudden demand and sometimes there is a fall in the demand for the productions. We have to utilize our resources efficiently and a high degree of customization. So what an industry needs to do, we have to reduce our programming time, okay? Accelerate machining, maximize resource utilization, control our production costs, and achieve quality requirements. And how we can do this is basically embracing to Industry 4.0, what we have been talking about since morning. But if we see the conventional plants as of today, okay, still over 50% of the manufacturers are using standalone systems. Over 30% are managing and controlling their data for smart manufacturing. And almost 61% of the organizations are still relying on paper-based communication. So generally the operator will go take the reading and give it to the manager for report generation. So how Industry 4.0 can be adapted to reduce and these kind of activities and increase your productivity. So as I said, we have been operating into silos. The manufacturing plant is working differently. The product engineering is working differently. The production data is working in a different. So we need to connect all the system to a single platform, which requires a seamless data flow across the manufacturing process, and then we can. This is what we call it as a say vertical integration across the manufacturing process. So this slide has been already been shown by my earlier presentation, so I'll skip this. Yesterday's often today's manufacturing the pyramid against the near future. Let me try to address the IT-OT integration. Okay. Now, if you see generally in any plant, we have 4 layers of operations. At the machine layer, it is nothing but your automation systems, where you will be having the conventional data. This is, I think this was one of the challenges what was showcased, that we are not able to pull up the data from the old and the conventional machines. Okay. Second layer is your monitoring layer, where you have got the HMI or the SCADA system, where you are operating your plant. And from the top, if you see, is your enterprise level layer, where you have your MES system installed. Okay. The biggest challenge for the integration of this IT to your OT network is the acquisition of the data from the bottom layer. So what I will be doing is, I'll be showing you 3 use cases, okay, how you can implement this IT-OT integration to your organization. So this is what we talked about. For example, you have got n number of machines, maybe some proprietary machines with third-party systems, irrespective of the automation supplier. Okay, it has to be Siemens, Mitsubishi, Omron, any supplier. You can pull up the data using an IoT device, and from IoT you can send it to the cloud using MQTT protocol. So this is a simplest communication gateway to send the data to cloud, and then you can analyze the data at the cloud. We have seen some sample dashboards earlier. Okay, so this can be done, and it could be any third-party cloud. It could be Siemens, AWS, or Azure. And the data connectivity at the field device, you can connect through OPC UA, Modbus, Ethernet. So there are multiple gateways available as of today. So this one simple architecture. Going to the second, instead of putting an IoT, we can put an industrial edge as a gateway. Okay, how industrial edge is different from an IoT based solution is, in industrial edge generally we will do the processing of the data or the computing of the data at the premise level or at the industry level without sending it to cloud. Only the required KPIs you would be sending it to cloud for monitoring it remotely. And the simplest way of integrating it, if you have got a very single plant with 10 number of machineries, you can do it using a SCADA. Okay, a simple SCADA can also solve your dashboarding problem. So we can just connect the data to a SCADA, and from there we can send it to a cloud. Now, in which scenario we should use SCADA, in which scenarios we should use edge, and in which scenario we should go for a cloud-based architecture. Okay, so generally if you have manufacturing plants segregated across different locations, okay, maybe 3-4 factories at different locations, there you can go for an IoT based architecture, because then you have to send the data to cloud. And IoT based architecture will have its own limitations, because if you are sending it to cloud, it's a subscription based model generally. You have to pay for the yearly subscription for AWS, and it also depends upon the amount of data that you are sending. Okay, so this is one thing that you have to keep in mind. Secondly is the security, because many of the manufacturers would not be willing to send their data to cloud because it's a private data, and I don't know how secure it is in the third party cloud. So that is the second challenge. And the third issue for sending the data to cloud is basically the high frequency data. Okay, for example, there could be a latency because there are a number of devices connected, and if I'm sending it to cloud, the high frequency data might not be updated at the required time. Okay, so these are the three major challenges, and that is where we can adapt for an industrial edge technology. So generally at edge, what happens is the computing what you are doing at cloud, the same computing will be done at your plant premise level. So your data is within your plant premise, it is not going outside, so it is a secured at your level, faster processing of the data, plus there is no subscription charge because it's a on-premise solution. And even if you want to monitor it remotely from some other location, still you can send only the KPIs at the cloud level and monitor remotely. And the third option is if you don't want to do any analysis, simple dashboarding is required for your KPI monitoring and report generation. In that case, you can go for a SCADA-based solution. Simple dashboarding using a SCADA can be done, and it is the most economical solution available in the market as of today. No recurring cost, the data is at your premise, and you can do the dashboarding and reporting in the plant level itself. And it is also possible to monitor the SCADA screens remotely. So there are functionalities available like web server where you can give a static IP and monitor and control the dashboards from a remote place. So it is very simple, and it is easily adaptable. It is not a very complex rocket science anymore to embrace Industry 4.0. The only thing is we have to identify the value. For any project, we need to understand the KPI that I need to monitor. Then we have to think on a bigger picture, and we have to start small. Okay. So to start with, we can go for a selected POC for a particular machine, and then we can scale it up as required. So that's it from my side. Thank you so much.
Thank you, sir. Thank you for keeping it brief and for showing the way to the Indian MSMEs for embracing automation in the shop floors. The last address is from Mr. Parth Kulkarni, DGM, Automotive Research Association of India.
Good afternoon. To begin with, I would like to thank the organizers for having us, ARI, here for the session. Being on the product development, testing and certification side of things, it's a great insight from the esteemed speakers here on technological development in manufacturing. I'll be giving the presentation on a slightly different topic, automation of the product itself from point of view of automobiles. Before we talk about the automation, please allow me to introduce ARI. Sorry. Automotive Research Association of India. We are basically located in Pune. We have more than 55 years of experience in India-specific testing condition, not only in testing but also in product development and R&D. With 700 plus manpower, mostly in the technical domain, and 16 specialized labs we have, each one specializing in one automotive domain, such as passive safety, structural dynamic, powertrain, NVH, and so on. We also have 3 center of excellences, mainly in green mobility, fatigue and materials, and powertrain. As I said, our head office is in Pune with 3 testing centers also located in Pune and around Pune. We have regional offices in Chennai and Hyderabad. So these regional offices are there to assist the local industries, be it MSMEs, OEMs or startups. There are also 2 regional centers coming up, one in Ahmedabad and in Delhi. As also my colleague from CMT have explained, we have common engineering facility centers coming up in Bangalore and Guwahati. These are mostly specific for development of ECUs. Many of our labs are already equipped with capabilities Many of our labs are already equipped with capability as per international standards, such as Federal Motor Vehicle Safety Standards, European standards, or Japanese standards. We also provide support for export homologation to countries like Australia, Singapore, South Africa, and Gulf countries. And we are in discussion with few other countries for accepting our certificates. So coming back to the topic of automation of product, that is from vehicular point of view is autonomous vehicles, and a subset of that is semi-autonomous vehicles, or as we call them, ADAS functions. The general consensus among the industry currently is that the current technology is not sufficient to address fully autonomous vehicle, that is a level 5 autonomous vehicle. I'll explain the levels in the next slide. Whereas the technology is sufficient for ADAS functions. So ADAS is basically involvement of mechatronics, AI, ML, and it's basically a multi-agent system. So these are the autonomy levels. Let me run you through. So L0 is no automation. The current cars what we drive are at 0 level of automation. So L1 is driver assistance, wherein the vehicle autonomously can control either the steering or the speed, but not both at the same time, also under very specific circumstances to assist the driver. L2 is partial automation, where vehicle can control speed and steering autonomously under normal environmental conditions. L3 is conditional autonomy, where the vehicle controls speed, steering autonomously under normal environmental conditions, but with the driver assistance. The driver needs to monitor it continuously. L4 is high automation. L4 and L5 are towards higher autonomy, where the vehicle can control speed and steering autonomously under normal environmental conditions without requirement of the driver. And L5 is full automation, where the vehicle can control all the environmental conditions without any assistance. So so the basic question is, why do we need the ADAS functions? When our vehicles are already running on the road, we can drive the vehicles. So what is the need, except for the fancy features, what is the need of ADAS? So let me give you some data. So if you see the chart here, what it shows is the accident data. So 80% of our accident data are due to driver errors. It can be due to fatigue, it can be due to negligence. So ADAS or advanced driver assistance systems, it has safety as its core objective. So with the use of ADAS, we can substantially reduce the accident data, the accidents or any other safety concerns. So, but for implementing ADAS, there are a lot of challenges with the deployment of ADAS in Indian conditions. So I'll just go through what are the challenges in implementing the ADAS. So you can see these are the different Indian use cases. To implement ADAS, we have to develop the functions which can handle this. So if you see the first image, it shows the complexity of automated driving functions. You can see this scenario is very common in Indian cities. The second one is weather conditions. Our roads and networks are not developed such that if a heavy rainfall comes, you will see flooding all over the place. Our road networks are poor with potholes everywhere. So these are few of the challenges which the functions should address to. The second are the infrastructure. So we don't have a standard infrastructure as like in the Western countries. So everything is slightly here and there. So for example, the height constraint barrier, it is not standard everywhere throughout India. Sometimes it's at a higher level, sometimes it's at a lower level. The speed breaker, sometimes some part of the speed breakers are missing. There are signals which come up with all the 3 lights at the same time. There are broken trains and so on. So all these conditions need to be addressed with the ADAS technology, what is being coming on the Indian market. So taking all these challenges and India's specific use cases into consideration, we are trying to research and implement various solutions. So basically we talk about three main aspects. One is India specific data generation. Here we are equipping a car with multiple sensors like camera, LiDAR, radar, GNSS, and capturing data all over India. The second is the solution for Indian use cases. So with the acquired data, we are trying to build a model which can facilitate these cases. And third, once the model is developed, we have to see if those models work in the real cases. So we follow an integrated testing and validation approach. As I mentioned, we are developing Indian databases and relevant use cases. So for carrying out these cases, for verification and validation of these cases, it's a 4-module integrated approach. First is getting the Indian database, then converting that to the digital domain. Then same is used in the digital data used in verification and validation with XIL, that is software in loop, machine in loop, hardware in loop, and driver in loop. And once that is done, the testing is done on the component level. Then we do the vehicle testing on the tracks. So this is the India specific database. So currently the database what is available is with the global data sets. So that is mostly from US and European traffic condition. As I said, these are the challenges what we face on Indian roads. So to generate the India database, we have equipped a vehicle with all these sensors such as LiDAR, cameras, and ultrasound sensors, and so on. So we have been collecting this data throughout India. So to actually build a case, you need thousands and millions of kilometers of data. So we have been doing this, and after collecting the data, you also need to validate those data sets. So that we are doing. Once that is ready, we can make it available to the industry. So whoever is working in ADAS or AVs can have this data set. So the second level is to digitize the data. So the whole data is completely digitized with different softwares and tools. Once the data is ready, then we have to integrate the data for a actual test case generation. So that is done through some tool chains, and then the same is used in MIL, HIL, or DIL. So anyone who is working on this, maybe at component level, can get their products verified with this tool chain. And the last part of it is the test track. So we are building a ADAS specific test track in Pune. So once the your component is ready, it is integrated into a vehicle, and all the tests can be carried out at this at this test track. So the test track has all the features which are there on the Indian roads. So these are the test equipment which are used for testing the vehicle. So these are the motion platforms. These are the test dummies which are mounted on the motion platform for testing. These are driving robots which are used in the vehicle to automate a test function. Software and network is there to automate the whole process. These are the additional modular road infrastructure which we use. And if time permits, I can show a video. Okay. So thank you. That's it from my side. So if anyone is developing MSMEs or startups related to ADAS or AVs, please do get in touch with us. Thank you.
Thank you, Mr. Kulkarni. Thank you for your address. And due to paucity of time, we will not have a formal Q&A, but the speakers are here, and if the audience wishes to interact, they can do so after the session. I now invite Dr. J. Mohana Sundari to present the formal vote of thanks.
Good afternoon to one and all. Thank you very much for each and every one of you. First of all, I thank our Honorable Chairperson of EPC for inaugurating this session. And my thanks to all the esteemed speakers who enlightened beautifully 4.0, starting from 4.1, 2, 3. And 5.0 also, and also into X, and 2 are from Coimbatore Genetic and PSG Tech, starting from the knowledge, and Siemens and Mr. ARI, for explaining each and everything. And no other way, nowadays it is no other way except smart manufacturing, smart company. Only we can increase our quality and we can compete in the international market. So let us all take away, lot of takeaways and many eye-openers for us to take away. And all the industries who are participated in this, I thank each and every one of you. And I request EPC team to give the email ID and the presentation so that because each one is needed 1 hour for the presentation. Or in fact, one day you can keep on talking about automation and industries. So I thank each and every one of you for making it, and please give your presentation so that all the guests can take in contact and we get the knowledge, and all the supportive team for making it a successful one. Thank you one and all for making it. I don't want to.
No, just be on the desk. Thank you. May I request the speakers and Mr. Arun Kumar Garodia, Chairman EPC, to kindly join us on the dais for a group photograph also. Please take this. Harish, chair lagao. I also request Mr. Arun Kumar Garodia, Chairman EPC India, to kindly felicitate our speakers with a memento. I request him to kindly present a memento to Dr. M. Sundaram, Associate Professor, PSG College of Technology. I request Chairman Sir to kindly present a memento to Mr. Gopi Krishna, Scientist D and Group Head, Precision Machines and Aggregates, CMTI. Next, I request Dr. J. Mohana Sundari to kindly present a memento to Mr. S. Sunil Kumar, Head Applications, Genetics India Private Limited, and also representing the Automation Industry Association. I request Dr. J. Mohana Sundari to present a memento to Mr. Abhishek Pandey, Senior Manager, Siemens Limited. I also request Dr. J. Mohana Sundari to present a memento to Mr. Parth Kulkarni, DGM, Automotive Research Association of India. I request all of you to kindly join us for a group photo.